friends, are you ready? It's day 4 of our Apex exercises. Today we will tax the next 3 Apex tasks from appsandbox.io. You ready? Let's go! Alright, this is exercise number 5. It says even or odd. Given an integer, return even if the integer is even or odd if the integer is odd. Remember to use math.mod function. Okay, math.mod. I forgot what how math.mod works. So let's try this. I think math.mod calculates if there is a remainder. Okay, integer remainder equals math.mod num divided by 2. So is there remainder? So math.mod. I forgot how math.mod. Apex math.mod. Math class. Let's check out the mod class. Mod method. Mod integer 1 value 2. So 1 2 math. Okay, so 12 divided by 2, there is a 0 remainder. Okay, math.mod. Okay, so it's like this. That's how it works. That's a signature. Okay, so if rem equal 0, return even, otherwise return odd. Okay, let's check. What happened? Unexpected token public. Oh, I forgot it. If Frank was right here. Something wrong. Okay, here we go. Right. There we go. I forgot these semicolon. All right, let's go tackle the next. Rock beats scissors, scissors beats paper, paper beats rock. Implement the method rock, paper, scissors. It takes as parameters 2 strings, player 1, player 2, representing the moves the players played by 1 and 2. Valid moves being rock, paper, and scissors. Return 1 if the player 1 wins, 2 if the player 2 wins, 0 if no one wins. Okay. If player 1 equals, if player 1 equals rock and player 2 equals scissors, return one. Okay. If player 1 scissors, and this is paper, player 1 and paper, rock, otherwise return 2. Okay, if any of these happens and player 1 wins, in other cases player 2 wins. All right, let's check. Line 2, player says play 2. Oh, it should be player 2. Okay, let's run now. 3 tests failed, 6 tests passed. If it's rock. All right. If both are same, if player 1 equals rock, and this one is rock, if this is scissors, this is scissors, if this is rock, paper, return 0, right? Should be return 0. So if both throw the same game, rock, scissors, paper, then it's a tie. Boom. Let's go next one. Given a person's age, return their age group as a string. Infant for age 0, 1. Oh, this one seems so easy. It's too easy, okay? Because it's saying if n is greater than 0 and n is less than 1, then return infant if n is greater than 1 and n is less than greater than equal to, so less than or equal to. Yeah, so if the kid is 0 or 1, they're an infant. If the kid is like 2 or less than or equal to 14, then the kid is, then it's a child. If the kid is n is greater than 14 and n is less than or equal to 21, that's a youth? A 20-year-old, you're a youth? There is no teenager. In other cases, then it's an adult. All right, let's check. Zero. Infant. Okay, it should be capitalized. Child should be capitalized. Youth should be capitalized. A should be capitalized. Okay, now let's run. All right, since these were so easy, let's do one more, okay? Companion plants. Some plants are considered companion plants. They grow better when planted next to each other. For the purpose of this problem, we consider the following plants to be companions: lettuce and cucumbers, lettuce and onions and carrots, and onions and tomatoes. Write a function is companion takes as input 2 strings, plant 1 and 2. If the 2 plants are companion plants based on the criteria described above, return 2, otherwise return false. This is also quite, we just do a match. If plant 1 equal to, so what are the companions? Lettuce, and plant two equals cucumbers. Let's do this. Or let's do the same thing, but just switch it. So this is plant 2 and this is plant 1. Then return true. This is plant 1, plant 2. Boom, boom. So lettuce and cucumbers, we cover this one, lettuce and onions. Lettuce and onions. Onions. Return true. Okay, lettuce, onions. Now next one. Onions and onions. And carrots. Onions and carrots. So plant 1 is onion, plant 2 is carrots, plant 1 is carrot, is onion. Okay, so they gotta switch. Now the last companion plant is onions and tomatoes. Onions and tomatoes. Onions, tomatoes. Okay, let's just double check. Plant 1 is lettuce. Plant 1 is cucumbers. Plant 1 is lettuce. Plant 1 is onions. Plant 1 is onions. Plant 1 is carrots. Onions, tomatoes. Okay. So if all these are true, then it's companion. Otherwise, it is not companion. Okay? Let's check. Assertion failed. Assertion failed. 4 failed, 10 passed. Okay, let's check why this one failed. Okay, what I like to do is copy this and paste it here. And onions and lettuce are companion plants. Onion and lettuce. Onion and lettuce. Onion and lettuce are companion plants. Lettuce, cucumbers, lettuce and onions. Okay. Lettuce. Okay, there's a 2 T's for lettuce. Okay, my mistake. Okay. All right, now let's run. Okay. All right, guys, let's do one more. You guys enjoying this? I hope you are. Let's do one more. Leap year. A year is considered a leap year if it is evenly divisible by 4, with the exception of years that are also divisible by 100. Years evenly divisible by 100 must be evenly divisible by 400 to be considered leap years. Okay, this one is more challenging. Okay. Implement a method is leap year that takes as an input an integer and return true if the year is leap year and false. So let's use that math mod. Integer remainder equals math.mod year 4, right? So If the remainder is 0, then it's a leap year. But what if the year is like 100? Of years are divisible by 100. So 100, 200, 300, 400. So they are not leap years. Okay. Integer div 100. Okay. Math.mod year 100. So if the year is divisible so why don't we just divide by 400? If the year is divisible by 400, then it's a leap year. Okay. If REM equals 0 and 100 equals 0, then return true, otherwise return false. Okay. 400, okay. Let's fix this. Alright, let's check. 2 tests failed, 6 passed. Okay, let's check which one failed. Alright. Um, 704 should be a leap year. Alright, this is true. So if it's so if it's a leap year, if it's divisible by 400 or divisible by 4. Maybe this should be, make this as an or. Okay. Right, almost all the tests are passing now. Let's check this one. Should not be a leap year. Alright, let's check this 100. Alright, so if it's not equal to 0. So it should be divisible by 400, but should not be divisible by 100. Alright. 1100 should not be leap year, so 1900 should not be a leap year. So let's check again. 1900 should not be leap year because it's divisible by 100. But it's divisible by 0. Okay, let's make this separate. Make it first. If return true. So if it's 1900, so what if we have 1900, it would be, what's 1900 divided by 1900 divided by 400 equals 4.75. Okay, this should work. Oops. What did I make? 400. Okay. If 400 equals 0 and 100 return true. Okay, there's an extra packet here. Okay, still this one is failing. Should not be a leap year. So if it's 1900 coming through here, it didn't pass here, but it's passing here. How do I prevent numbers that are divisible by 100 from getting cut here? All right, I'll do this string zeros year string dot value of year. Okay, boolean hunt equals zeros ends with, okay, if hunt true, return false. All right. This probably was not the ideal solution. I'm curious what the faster solution would be. This took me 11 lines of code, 10 lines of code. How could I do this faster? All right, let's put this in ChatGPT and let's check what ChatGPT would do. All right, let's take a look at ChatGPT. All right, 1, 2, 3, 4. That's 4 lines of code versus my 10 lines of code. If year, okay, let's check this. Will this pass? Yeah, this doesn't exist in Apex. Yeah. You should have used math.mod. All right. So just, if you can solve this in fewer lines, please leave it in the comments. I'd love to hear from you. That's it for today. I hope you enjoyed the video. See you tomorrow. Bye-bye.